Welcome to True Projects. In this video, we are going to explain about a project titled AI-based stroke disease prediction system using ECG and PPG biosignals updated. The primary introduction of this project is to create a sophisticated healthcare solution that effectively detects and predicts the strokes at an early stage. The system achieves this by harnessing the capability of the AI and analyzing the crucial biosignals such as electrocardiogram and PPG signals. Through this analysis, the system accurately identifies the potential stroke risk in patients, enabling the timely intervention and personalized healthcare recommendation. To bolster its predictive accuracy and real-time monitoring capabilities, the project emphasized the integration of the state-of-art algorithm and the larger dataset. By significantly improving the stroke prevention and the patient outcomes, the system aimed to elevate the burden of stroke-related disability and reduce the healthcare cost, paving the way for more effective and accessible medical intervention. The main aim of this project is to create a comprehensive and robust disease prediction system by employing a wide range of machine learning algorithms such as CNN, hybrid CNN, LSTM, bidirectional LSTM, CNN and BiLSTM, random forest, decision tree, Neo-Bayes, AdaBoost, and the logistic regression, MLP-ANN, SVM, voting classifier, BF-tree, and Bayesnet. By harnessing the potential of these algorithms and analyzing the relevant medical data, the system strives to achieve the accurate disease outcome prediction, facilitate the early diagnosis, and deliver the personalized treatment recommendation. The project's ultimate goal is to enhance the healthcare efficiency, mitigate the misdiagnosis rate, and significantly improve the patient outcome and the overall quality of life. Through the implementation of cutting-edge technology and machine learning techniques, the disease prediction system seeks to revolutionize the healthcare industry approach to disease detection and the management. And these are the basic requirements that are needed to build this project. Software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, and Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. Python libraries such as NumPy, Pandas, Matplotlib, and sklearn are imported to facilitate the data manipulation, visualization, and the machine learning tasks. And the second one is importing the dataset. The dataset comprises health-related features including age, sex, heart rate, and diagnosis, and many more. It serves as the foundational data for the training and testing the disease prediction model. And the third one is data visualization. Exploratory data analysis techniques are applied to gain a deeper understanding of the dataset characteristic and explore the relationship between the different features. And the fourth one is building the model. Several machine learning algorithms are included. The first one is CNN. CNN stands for Convolutional Neural Network. It's a deep learning algorithm well suited for the sequential data analysis. In this project, the CNN is employed to extract the relevant feature from the ECG and the PPG biosignal. It can learn the intricate pattern and the relationship from the temporal data, aiding in stroke disease prediction. Its ability to automatically learn the hierarchical feature can enhance the model's accuracy in detecting the subtle abnormalities in the signals. And the second one is hybrid CNN LSTM. It is a combination of the long short-term memory and the convolutional neural network. It effectively processes both the spatial and the sequential data, and the context of this project leverages the CNN feature extraction capability while preserving the temporal dependencies of the sequential data using the LSTM. This hybrid approach can potentially improve the model's ability to capture the complex pattern in the ECG and the PPG biosignals. And the third one is LSTM. It stands for Long Short Term Memory. It is a specialized variant of the recurrent neural network designed to address the vanishing gradient problem in the long sequence. And this project, the LSTM can analyze the sequential ECG and the PPG data to identify the temporal pattern and the dependency related to the stroke disease. LSTM memory cells can effectively retain the relevant information over the long time interval, making it suitable for analyzing the dynamic time series data. And the next one is bidirectional LSTM. It extends the capability of LSTM by processing the data into the forward and the backward direction. By leveraging the past and the future information, this algorithm can capture more comprehensive temporal dependency in the ECG and the PPG sequence. And the next one is CNN plus bi-LSTM. This approach combines the CNN and bi-LSTM to exploit the complementary strength. CNN can extract the spatial feature from the ECG and the PPG signals, while bi-LSTM captures the temporal dynamics. The integration of these algorithms can result in a powerful model with a comprehensive understanding of underlying pattern and the relationships. And the next one is random forest. Random forest is an ensemble learning algorithm that constructs the multiple decision tree during the training and output the mode of the class as a prediction. In the context of this project, random forest can be used as a classifier for the stroke disease prediction, leveraging its ability to handle the high dimensional data and the non-linear relationship between the features. And the next one is decision tree. Is a tree-based algorithm that recursively splits the data based on the feature value to make the prediction. And this project, the decision tree can be utilized as a classification model to predict the stroke disease based on the input biosignal. Its simple and interpretable structure can avoid the insight into the significant feature contributing to its prediction. And the next one is Bayes. Bayes is a probabilistic algorithm based on the Bayes theorem. Assuming the independence between the features, it employed as a classification model for the stroke disease prediction, its simplicity and efficiency making it a suitable choice, especially when dealing with the larger number of features. And the next one is AdaBoost classifier. AdaBoost is an ensemble learning method that combines the weak learners to create the strong classifier. In this project, AdaBoost can enhance the prediction performance by iteratively adjusting the weights of the misclassified sample, emphasizing the difficult case and improving the overall accuracy. And the next one is logistic regression. Is a linear classification algorithm that models the probability of an instance belonging to a particular class. In the context of this project, it can be used as a binary classifier to predict the stroke disease presence or absence based on the input biosignals. Its simplicity and the interpretability makes a useful benchmark model. And the next one is MLP-AN. MLP is a class of the feed-forward artificial neural network that consists of multiple layers of the interconnected neurons. It can be employed as a classification model for the stroke disease prediction, leveraging its ability to learn the complex relationship between the features and the hidden patterns in the data. And the next one is support vector mission. Is a powerful supervised learning algorithm for the classification task. And this project, SPM, can be used as a classifier to predict the stroke disease based on the input biosignal. SPM seeks to find the optimal hyperplane that best separates the classes, making it effective in the high-dimensional data. And the next one is voting classifier. It combines the prediction of multiple models to make the final prediction. In this project, the voting classifier can integrate the output of the different classifiers to achieve a more robust and accurate stroke disease prediction. And the next one is BF3. That means also known as Bayesian network, is a probabilistic graphical model representing the relationship between the variables using a directed acyclic graph. It applied to the model causal dependencies between the different health features and assist in the stroke disease prediction. And the last one is BaseNet. It is similar to the BF3, represents the probability relationship between the variables using a graphical model. It can effectively capture the dependency between ECG, PPG biosignals and stroke disease, providing the valuable insight into the disease prediction process. And the accuracy comparison graph. The performance of each model is evaluated and their accuracies are compared to identify the most effective algorithm for accurate disease prediction. And the next step is training the model. The selected model undergo the training process during which they learn the pattern and the relationship between the feature and the corresponding disease diagnosis. And the next step is user gives the input. A user-friendly interface using the Flask framework is developed, allowing the user to give the input their health-related information for the disease prediction and the risk assessment. And the next step is the given input is pre-processed for prediction. The input is pre-processed to ensure its compatibility with the trained model, including the handling missing data, normalization, and the feature scaling. And the next step is trained model is used for prediction. The pre-processed user input is passed through the trained model to predict the likelihood of the potential stroke disease and identify the possible risk factor. And the last one is final outcome is displayed. The model's predictions are displayed to the user, providing the valuable insight into their health condition and enabling the early detection of the stroke disease. Personalized treatment recommendation and the risk mitigation strategy are suggested, enhancing the overall healthcare management and the patient outcome. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the folders like of CSS, JavaScript, font, images and uploads and the bootstrap files within it. And the template folder containing of the HTML documents like about, home, index, notebook, results, sign-in and sign-up pages within it. And the app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the dataset as the user and this project, and the model is a file that contains the algorithm information, and it will be loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNP file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database used to store the user information. And to execute the project, first we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk to F because our code folder is present in F disk. Then write a command cd space and paste this code folder path. By this it will change the directory to the code folder's path. And then write a command that is python space app.py. By using this command, it will execute the Python script and perform a runtime check for any syntax errors and the logical issues. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this local link and paste it on any web browser. I prefer to use Chrome. I'm pasting this link and clicking the enter button, we redirect it to this home page containing of the home and sign up buttons. Click on the sign up button. We redirected to the registration page containing of some necessary details that are need to be filled to create an account. But my account is already generated, that's why I'm using the sign in button. To get off the sign in page, here we need to enter the username and password as of admin. And then click on submit button. Here it redirected to the index page where we need to enter the some details as of like this. I am entering the age as of 55 and select gender as of male and enter the value of height as 175 and enter the value of weight as 94 and enter the value of QRS duration as of 100 and enter the value of PR interval as of 202 and enter the value of QT interval as of 179 and enter the value of T interval that is 143 and enter the value of P interval that is 28 and enter the value of QRS that is of 0 and enter the value of Q wave that is of 72. Enter the value of R wave that is of 20 and enter the value of S wave of 0 and enter the value of 0 and the S wave as of 48 and the AA wave of S wave as 0 and the AA wave of 48 and the AB wave of 0 and the AC wave of 0 and enter the value of AD wave as 0 and the AE wave of 0 and enter the value of AF wave as 0 and the AG wave as of 0 and the AH wave as of 64, AH wave also 0 and the AI wave of 64 and the LG wave is of 62, and then click on the submit button. Here it redirected as not diagnosis as stroke disease based on the ECG and the PPG feature values. And this way we can detect the stroke disease by using the ECG and the PPG feature. And this is the accuracy comparison graph where x-axis represents the accuracy of each algorithm and the y-axis represents the algorithms that are used in this project. And in conclusion, the project successfully developed an advanced disease prediction system utilizing a diverse set of machine learning algorithms. Through the integration of the CNN LSTM variants, random forest, neo-Bayes, and other powerful classifiers, the system demonstrated its potential in accurately predicting the disease outcome and aiding in early diagnosis. The combination of these algorithms allowed for comprehensive analysis and personalized healthcare recommendation, contributing to the improved patient outcome and reduced misdiagnosis rate, with the potential to enhance the healthcare efficiency and assist the medical professionals in making the informed decision. This disease prediction system holds the promise in revolutionizing the field of medical diagnosis and the treatment.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.